Hi everyone, and welcome to this video on quicksort algorithm in Python. Quicksort is a very efficient sorting algorithm that works by partitioning an array into smaller subarrays. Like basically it divides the array into subarrays and recursively it sorts the subarrays. And basically it is widely used in many applications. It has good great speed, and it is really simple. So let's try to implement quicksort algorithm in Python. So let's create a class solution, and basically we can create we can create the function, so we're gonna create the quicksort function. We're gonna pass the self parameter and the array, and since this is the recursive method or recursive function, so basically we're gonna define the base case, or like where we can stop the recursive call. So basically if the length of array is less than or equal to 1, at that time we want to return array. Else what we want to do, so we would like to partition the array. So we cannot choose on pivot element from the array. It can be any element in the array. But usually how it is done, either we select the first or last element of the array, but we can use any, we can select randomly or any element of the array. So let's select the first element of the array, that is the first element of the array, and then we would like to partition the array into two halves. So basically it can be half or basically into two partition. So if the element of the array is smaller than pivot, we're gonna put that into the left half. If that is greater but if that is greater or equal, then we're gonna put that into the right array. So let's create we have the pivot, so left and right. If we would like to partition, so this is the left, we would like to have the right, and we're gonna iterate over the array. So for I in range, so since first element is already gone, so I'd like to start from the second element, length array, and then we're gonna compare the pivot to each element. If it is smaller, it goes to the left. If it is like equal or greater, it goes to the right. So if ari, if this is less than pivot, it goes to the left. Left append I. Else what we're gonna do, right dot append I. So this is the recursive I mean recursive recursively we would like to do the same thing for all the elements. So we would like to recursively we would like to recursively apply these steps to the sub arrays. So at last what we're gonna do, so basically we're gonna return the quicksort to the left array, then pivot and right. So recursively we can apply the same techniques to the rest of the array. and then let's quickly like test how the block of this block of code really works. So let's create one like instance of this class solution, and let's try to implement the quicksort method of this class. So basically let's try to like use this example 2 1 5 3 9, and let's see what happens. So basically it gives us the like sorted array. So we input like 2 1 5 3 9. So once like we pass that to the function, it basically gives us back the sorted array. And let's talk about the time complexity of the solution. So in good case, in the best case of this solution would be like n log n. The worst time complexity for this solution is O of n square, and this happens when we have like the largest element every time or smallest element every time as the pivot. Thank you.